Let's start with the first writing of a relation and function. We use something called mapping. So this one we call it a mapping. This is a mapping for representation for a relation or a function. The domain should be to the left. So this is the domain, and the range will be to the right. As we see, we have one element in the domain has two images in the range. In this case, will never be a function, but still as a relation. So it is not a function because of one element in the domain has two images in the range. Okay. Also here, we check now every element in the domain has one image in the range. It doesn't matter one element as an image of two elements in the domain, right? So the domain here is the set of elements F, C, T, B, M. And the range is a set of elements F, C, T. So this is not a function but a relation. This is a relation. But this one is a function with the domain set of elements 90, 80, 70 and range set of elements A and C. What about this one? Yeah, every element in the domain has only one image in the range. So, yes, it is a function. And the domain will be moon, door, paper, tree, and the range will be -2 and 5. Last one, no, it is not a function. This is a relation, but not a function. So, all function will be relation, but not every relation is a function. Why this is a relation but not a function? Because one element here in the domain is not having only one image in the range. It has more than one image, so it will not be a function. Okay? Again, the domain here in the left, which is 90 and 70. Range here, the element to the right, which is A, B, and C. Again, just to be very specific, a relation in x and y is a function f for each value of x in the domain. There is only exactly one value of y in the range. Now, this function or not, yeah, this one we call it the ordered pair representation for the function or relation. To check this one a function or not function, we check also the domain. The domain is the x coordinate, which is to the left in the ordered pair. So if we find something repeated, it means one value in the domain has two images in the range. But all of them are different here, right? So it is a function. If you would like to write the domain, so the domain will be the elements to the left in each pair, 7, -1, -5, and 3. What about the range? and range is the element in the y coordinate place, which is R, and we know we found in repeated. So in the set there is no repetition, so we write it only once. So finish. Okay. So we don't care about the repetition in the y coordinate. We are caring about the repetition in the x coordinate, which is a domain, right? If you have a repetition in the domain only, it will not be a function, but no repetition here in the x coordinate. Here, now, we just enough to find one repeated, so it is not a function. So it is a relation. This is only a relation, right? Not a function, but relation. If you would like to find the domain, keep taking the left element. If this one is repeated, no need to take it twice. Okay, so the domain will be 1 and minus 2, and the range will be ZS only, because no need to repeat this one, because in the set, when you write in the set, no need to the repetition. Okay. Now, if we have this one, this is called the graph of a relation or function. In this way, we have to check again every element in X has only one image in Y. How to do this one? We just imagine we have a vertical line. So we go for vertical line for each element here. We have only one intersection point. So this is a function. Yes, function. But when we have here only one in is enough. So this is not a function. If we make the vertical line test, it is yes, because you whatever number of vertical line, you will have only one intersection point. But here it is not a function because you have more than one intersection point. Also, this one is not a function. Okay. This one, we don't care about any other point. We are caring about these 2 points. This 2, because one x has 2 different y. Y here is 4, y here is minus 2 for the same x, which is 3. So this is not a function. Okay. This method, we call it what? Yeah, we call it the vertical line test. This is the vertical line test. Now, let's go for finding the domain and the range. As we said, the domain is the set of elements to the left when you're having this mapping representation. So we have 1, 2, 3. What about the range? The range is the element to the left, which is 4, 5. Here you have as the order pair, as we said, the domain is the element to the left. Okay, so minus 8, minus 9, minus 6, minus 7. What about the range? The range is the element to the right. Okay, which is minus 9. Minus 9 is repeated many times, so we have only minus 9 as a range here. Sometimes give you the order pair as a table, right? Hour of studies, he called it the independent variable x, and the test score called it the dependent variable y, or the function of x, right? So the domain is still the element for the independent variable here. So the domain is 8, 3, 11, 5, 8. Ordering in a set elements, no need to order them. If you would like to order them from the smallest to the biggest, that's up to you, right? And the range is the element of the dependent variable. Now we know how to find the domain and the range for a relation or a function when we have it in a mapping representation or ordered pairs, right? If we have a graph, can we find the domain? Yes, the domain is a value of x as far as I know now. So how to find the x value? Come from the left, go to the x-axis, so you will find minus 3, and go for the next point. To the x-axis, you will find minus 1. For this one, yeah, here we have x is 0 and y is 0 as well. For the next one, we have x equal to 2. So for the domain, you find the value of x. How to find the value of x? You just come from near the point and go to the x-axis vertically. Okay, what about the range? The range is the value of the dependent variable y. How to get y from the first one is minus 4. Go for this one. No need to move to y because itself it is in the y-axis. So y is 1. For this one, y is 3. For this one, y is 4. For the last point, y is 4 again, so no need to repeat it. So this is the range. When we have a continuous graph like this one, okay, so to find the domain, we come from the left, and we know the minimum value of x from which is minus 3. Okay, and we carry on to the right, and we check the value here is 5, but we still have arrow, so it will be extended. So extend to what? The far right is positive infinity, right? Minus 3 has a hole here, so minus 3 is not included, so it is open interval. And with plus infinity or minus infinity, we use also open, right? This is the domain as interval notation. Okay. What about the range? The range, to find the range, we come from down to up. So down to find the minimum value of y. So remember, we are caring about y here. So the minimum value of y is minus 2. And because there is a hole here, it is open, it's not included. If there is no hole, we have a square bracket to be closed interval. So come from down to the up. The far up with this one will be also positive infinity. This is how to find the domain and range. Be careful with the hole and the arrow. For this one, go for the domain. Domain is a value of x, so I come from the left to right. So the value, the first value, yeah, remember you have an arrow, so you can extend it to minus infinity to the left, and also to the right you can go for positive infinity. What about the range? The range is carrying from down to up, so the minimum value, because we have an arrow, we go far down, which is minus infinity, and the maximum value here is 4. 4 is included because there is no hole, so we use a square bracket. This is a closed interval. Okay, this is how to find the domain and range in different representations. Let's go and check yourself to find the domain and the range for this one. We come for the domain related to x. So come from the left. We have an arrow here, so it will be the far left, which is minus infinity. And yes, remember you stop here at 3. 3 is included in the first part, and the rest to the right of 3 you can say union or. This is, you call it or union. Okay, Union what? Yeah, you start again from 3, but this part is not included to the right of 3 up to the maximum value of x because it extends far right, which is positive infinity. This is the domain. What about the range? I would leave the range for you. Okay. Let's see some uh, functions we know before. This is the linear function. Yeah, I remember linear function represent a line. This part is b, so if b is equal to 1, and if you get any 2 points, say this one, so this one length is 1 and this is 2, so if you divided 1 by 2, you have something called the slope 1 over 2, right? This one also, if you take these 2 points, you will have the same value 1 over 2, the rise over the run. Okay, so the slope is the difference of y over the difference of x for any 2 points. And sometimes they call it the rise over the run. Okay, remember, because you are going from left to right, you are going up, so the slope is positive. Okay, if you're going down, the slope will be negative, right? If we have b equal to 0, so we will have y equal to mx. This is the line passing through the origin, right? Because as we said here, b is the part of y cut by the line, okay? Now let's go for the quadratic function. The quadratic function formula is ax squared bx plus c. A is playing the main role in this function. If a is positive, it will be open upwards. But if a is negative, it will be open downward. This shape, we call it parabola. How to find the turning point or the vertex? Here, we call it the minimum. Here, we call it the maximum. How to find this one? What is the formula to find this one? The x coordinate for the turning point or the vertex is minus b over 2a. Once you find x, plug in this value of x in your function to find the y coordinate for the vertex point or the turning point. Okay? Before we leave, here to find the x-intercept, uh, okay, you put y equal to 0 to find the x-intercept. So if you put y equal to 0, it means ax squared plus bx plus c equal to 0. This one has a formula to solve this one, which we call it the quadratic formula. So x will be minus b plus or minus root square b square minus 4ac over 2a. Or you can use your calculator to find the roots which represent the x-intercept. The absolute value of function is defined as x equal to 0 and x equal to 0. X is positive when x is positive. X, the absolute value of x is minus x when x is negative. This is exactly like playing Billiardo. Sometimes you play like this. This is a V shape. Okay. This is how it looks like when you graph the absolute value of x function. This is a constant function. Yes, we don't have x, right? This is what we call it a constant function. So x equal y equal to 5 So it means y equal to 5 whatever x is, right? So the domain here for the const function domain is all real number x or related, all real number, right? Or you can say minus infinity, positive infinity like this. This is the domain of this one, right? Because this function is defined for all values of x, okay? So the domain is minus infinity to positive. So when function of x equal to constant, we call it horizontal line, horizontal line. For the horizontal line, the slope equal to 0. This is why x disappears, because we have y equal to mx plus b. When x disappears, it means m equal to 0. So the domain is minus infinity to positive infinity, and the range is only one value, which is 5. This is quadratic formula. Yes, you have a equal to 1, b equal to 3, c equal to 0, because you don't have constant. Okay. And this is how to graph it using decimals or any graphical calculator. This is the turning point. How I can find the turning point? This x supposed to be minus b over 2a, so it is minus a, b is 3 over 2a, a is 1, so minus 3 over 2, which is exactly minus 1.5. X is minus 1.5. Substitute here by x equal to minus 1.5. You will get y as minus 2.25. For the x-intercept, this one, you put y equal to 0, okay, and solve this equation. 0 equal to x squared plus 3x. You can solve it by calculator by input a and b and c, okay, or you can take x as a common factor. When you have two things multiplied together equal to 0, it means the first one is 0 and the second one also is 0. We have this one. From this one, we move this one to the other side, so x equal to minus 3. This is exactly this 2-point x-intercept. What about the domain? As I said, coming from the left to right, because if you have an arrow here, you say from minus infinity to positive infinity. If you don't have, you just catch the minimum value here and the maximum value here to be your domain. The range starts from the turning point up to, if you have arrow here, to up to infinity, right? So if we can talk about the domain for this function will be, but if you have arrows, minus infinity to positive infinity. If you don't have arrows, you just take the left minimum value and the right, which is the maximum value of x. The range starts from the turning point, which is minus 2.25 up to what? If you have an arrow, so you will reach positive infinity. Because you don't have hole at the turning points, you can use the square bracket. This function has a problem, as every rational function has a problem when you have a denominator, and the denominator must be non-zero values, right? Because if you graph it by decimals, graphical calculator, or any graphical calculator, you have no values at 0, because you can find the value of the function at this point. And also to the left to the point, you have a shape different from the right of the 0, right? So when you come to the left, you have here minus infinity. When you come from the right, you have here positive infinity, right? We will talk about this one later on when we are talking about right limit and left limit and the continuity. So I forget to tell you what is the domain. The domain from minus infinity up to 0, 0 shouldn't be included, okay? Union yeah, 0 to positive infinity, okay, or all real x, any real value except 0, okay. So we sometimes they write it like this: all real number except 0 minus 0. This is the minus for the set, okay. What about the range? This is the domain. What about the range? The range will be also from minus infinity to positive infinity, except the function at 0, okay, because it is not defined. Now, this is the root, square root function. We have a problem with the square root when we have negative value under the square root. So x plus 1 should be greater than or equal to 0, right? So move this one to the other way to be minus 1. So x supposed to be greater than minus 1. So when you graph it, your graph would start from x equal to minus 1. Okay? So when you put x equal to minus 1, you have the function equal to 0. Okay? And once you increase x to the right of minus 1, you will start having a bigger value for the roots. Okay? Now, this is a rational function. Again, we have a problem at this one. So this one shouldn't be 0. So this one shouldn't be equal to 5, or x shouldn't be equal to 5 over 2, which is 2.5. So if you graph this one, you will have a graph has no value at x equal to 5 over 2. So we have to avoid 5 over 2. So your domain has everything in real values except 5 over 2. So when you graph it, yes, at 5 over 2 here, or 2.5, you cannot graph find the value of the function. Okay? So the domain will be minus infinity to 5 over 2 union 5 over 2 to positive infinity. Okay. You have another rational function, but remember x squared is always greater than or equal to 0. So if you add 4 to this one, you guarantee this is greater than 0, right? So you have no problem with x squared plus 4. So the domain will be yes. So the domain will be all real numbers. So the domain will be from minus infinity to positive infinity. Okay? I will let you see what is the range. The range is the minimum value of y and the maximum value of y. Check it. Now, also, we avoid having any negative value under the root square. So we move this one to the other side because just to get rid of the negative of. So t less than or equal to 2. Okay. So for this x, if we have x, we got 2 here, and we get everything to the left to 2 because it is less than t less than or equal to 2. Okay. So the domain, yes, from left to right, minus infinity to 2, but 2 is included, so we use the square bracket. Now, yeah, we graph the function, and we notice the function has to the left to the 2, but to the right to the 2, there is no values we can graph because it is not real value. Okay. So the domain comes from the left to the right. From the far left is minus infinity, and here we stopped at 2, so minus infinity to 2, but 2 is included, so minus infinity to 2 and 2 included. This is the domain. Okay. Now, this is the absolute value function. Okay. Absolute value function, as we said, is a V shape and always had no problem with any value for the variable inside this one, right? So the domain for this A could take any value. We have no problem with that. So the domain will be minus infinity and positive infinity. But the range, yes, the range, as we said, absolute value is always greater than or equal to 0. So the range will start from 0 included to infinity.